Let's once again use some coordinate geometry to figure out what kind of quadrilateral we're working with. So I've already gone ahead and plotted my points so I could see what this figure looks like, and I've written down the distance formula and the slope formula. We're going to need those for this problem, so if you don't remember those, I've written them at the top. I'm not going to actually work out the distance and slope this time, so if you need to do that, make sure you pause the video, or if you have the DMS program, you can use that. So even though I've said several times, we can't prove what a shape is just by looking at it, for these problems I would probably actually start that way and say, what does this figure look like to me? And it certainly does look like a square. Now that doesn't prove it's a square, but it at least gives me some things to think about in order to prove that this was going to be a square. So I'm going to assume this is a square and kind of prove that using some coordinate geometry. So one thing that I know for sure about a square is that I will have to have 4 congruent sides. And so the first thing that I'll do then is I'm going to use the distance formula to find the length of all 4 sides. So to find the length of PQ, and the length of QR, and the length of SR, and the length of PS. So there are 4 distance problems to do in this problem, meaning you either pause the video, because you'll definitely need to pause it to work that all out, or use your DMS program to find the distance of those 4 sides. But if all 4 sides are the same length, then I'm off to a good start in proving that this is a square. So I've kind of already gone ahead and done that work, and I found the distance of the sides to be the square root of 17, the square root of 17, the square root of 17, and the square root of 18. Just kidding. The square root of 17. So all 4 sides do have the same length, meaning that's pretty good evidence, or that's starting evidence that I do have a square. However, you guys know the other shape that this could be. The other shape that also has 4 congruent sides is a rhombus. So I've got one of 2 shapes I'm working with right now. I've either got a rhombus or I've got a square. So I need to do a little more investigation to figure out if this is indeed going to be a square. The other thing you know about a square is that you have 4 right angles, or 4 90-degree angles. And so let's work on proving that. To prove that you have right angles, what we can do is we can look at the slopes. And what I want to do to show that slopes are perpendicular is that I need to show that the slopes are opposite, meaning I've got one positive slope, and I need to show that they're reciprocal, or sorry, I need to show they're opposites, meaning one's positive, one's negative, and I need to show that they're also reciprocals, meaning I can take one fraction and flip it over. So that's the investigation I'm going to need to do next. So either using slope formula, or remember, it might be easier to just count rise over run, I want to find the slope of this line, and I want to find the slope of that line. And if I can show them to be opposite and reciprocals, I would know that I have a right angle, and if that one angle is right, since all the sides are equal, all the angles are going to be right, and I would have a square. So let's find the slope of PQ. I'm just going to do rise over run, because that's really easy to do just from the diagram. I can see that I have a rise of 1 and a run of 4. So side PQ has a slope of 1/4. For segment QR, I see that's going to have a negative slope because the line is decreasing. I have a rise of positive 4 and a run of negative 1. So a rise of 4 over a run of negative 1. So the 2 slopes I'm working with are 1/4 and negative 4 over 1. So remember, negative 4 over 1. So remember, to be perpendicular, I need to show that they're opposites, and I can see they are. One's positive, one's negative. And I need to show that they're reciprocals, meaning we can flip the fractions over and get the other one. 1 over 4 flip becomes 4 over 1. So yeah, those 2 slopes are going to be perpendicular, meaning I do have a right angle right there, which means finally I do have proof that this is not just a rhombus, this is going to be a square, because I've shown all the sides are congruent to each other using the distance formula, and I've showed that I have right angles by finding the slopes and showing their opposite reciprocals. So this figure is going to be a square.